Okay, so we would like to do 11.6, number 20. So we have the log of 7t plus 3 minus the log of t plus 1 is the not log of 5. What's the problem say? Good, cool. Reading the long line. ln of 6t plus 2. Better? Okay, good. All right, so now what?
Combine the logs on the left side.
Okay, so we could stick these two together using the division, subtraction, log rule thing, right? Log rule, mumble, mumble.
Yeah.
Okay, so we get ln of
7t plus 3 over t plus 1.
okay, cool. ln of 7t plus 3 over t plus 1, and that's supposed to equal
It's the same.
the other stuff.
16 plus 2.
Okay, log is 6t plus 2. Then what?
Just get rid of the logs.
Yeah.
Okay, how do you get rid of the natural logs?
You put them all in the exponent of an e.
Okay, so we take e to the stuff on both sides. Is that the stuff that was troubling you, Josh?
Yes, that's right.
Okay, so we think about this as a log with a base, right? And then we raise both sides into the exponent of a base. So that base for this guy is e. And then we just do this. And then it turns out that it doesn't really matter, right? Because what do we get?
They cancel and you get 7t plus 3 over t plus 1 equals 6t plus 2.
Okay, so we get 7t plus 3 over t plus 1 is 6t plus 2. And it didn't really matter what we did to both sides to get that, right?
Nope.
We just knew that because these two logs were the same, we were going to be able to undo them, right? Okay. If I had had the thing I started with, where I had an log over here, would I have been able to do that? No, because they're different bases, and I would have ended up totally screwed.
One question, if you
Yeah.
have like a problem that has ln and then they have loge, are those the same, those be considered the same thing? and
Yeah,
we're just,
so
like,
those are the
writing
same.
Two different things to mess you up?
Yeah, so if we had written a log base e, yeah, we could do e to both sides. Those really mean the same thing. If we had log base 10, then we'd have to try to junk around with the change of base formula, which is a pain in the ass.
Thank you.
Yeah, so we're going to ignore that. Okay, so we get to here.
Multiply both sides by t plus 1.
Okay, so we take this, we multiply by the bottom, so times t plus 1. We get 7t plus 3 equals, I don't know why I put parentheses around that.
Equals
T plus
6t
1 times
squared
6t
plus
plus 2.
3t plus.
Okay, t plus 1 times 6t plus 2. Then I FOIL. So I get 7t plus 3 is 6t squared.
Plus 8t
18.
plus 3.
8t plus
3.
2.
Not 2. That.
Careful.
Weird addition.
Write down your FOILs.
Ishness.
Okay? Do as I do, or no, do as I say, not as I do. Write down your FOILs. Okay, so if we were doing this right, we would say, okay, we got 6t squared out of the first. Then there's the
2t.
Outside. Inside, outside.
outsides, 6t from the insides, and 2 from the lasts.
Yeah.
Right? Okay, so now what?
Now we subtract 7t and 3.
Okay, so we apply minus 7t minus 3 from both sides. So we get 0 is 6t squared
Plus t.
plus t
Minus
Minus
1.
1.
minus 1. Okay, so now what?
And now you either factor or quadratic formula.
Okay, factor quadratic formula.
You want to do quadratic form.
Okay, so let's try the quadratic formula, because we haven't done that in a while.
True.
So how does the quadratic formula work again?
A is 6.
Okay, we need an A, a B, and a C, right? So A is, B is, and C is?
A is 6, B is 1, C is negative 1.
Okay, and then we need,
Negative 1 plus or minus
so negative b plus or minus,
square
Square
root.
root
Wait, yeah.
1 squared minus 4 times 6 times negative 1.
Over
2 times 6.
yeah.
and what's this supposed to be equal to?
T.
Okay. Okay, so I get, let's see, this is negative 1 plus or minus
Square root of
4 times 6 positive 1 is
25.
25.
25.
So plus or minus 5.
Over
So plus or minus 5 over 12 gives me
Negative 6. Over 12.
4 over 12 or negative 6 over 12, which is,
1/3.
1/3 or
negative
negative 1 half.
so I get t is a third or t is minus a half. Am I done? I circled these like I was done.
You want to
No, you want to
put them
plug it back in.
Yeah, we should probably check and make sure those things are actually positive. So let's see. I need to check a third. So
a third is 7 plus 3 is positive.
a third of 7 is positive, right? Positive, positive is positive. Check.
A third plus 1 is
A
positive.
third plus 1 is positive.
A
And
third of 6
That'll be
plus 2 is
positive.
positive.
that'll be positive. Okay, the negative 1 maybe I should worry about.
Yeah.
So
That'll be 7
3.5.
halves.
that'll be
Oh.
7
Negative
halves,
seven.
which is
Yeah, it's going to
negative.
be negative 0.5. It doesn't matter.
That'll be negative 3.5. Plus 3 is negative. Oops. No, it's not going to work.
Yay.
You guys see that?
I mean, all.
Don't get attached to the idea, right, that there will always be one that doesn't work, but oftentimes there will be, right? Where is that thing coming from? Why is that appearing in my life?
Because you have a plus or minus in your equation.
It's from this log rule right here. You guys see that?
He was right there. Then.
Here I had something that was negative and negative, and then I divided them and got something.
Completely different.
Oh, never mind. It's broken on both sides.
Oh. Psst.
Yeah. It's coming from
Negative 3
this
plus.
log rule and the fact that I eat both sides.
So after the
And then,
because negative 3 plus 2 is.
yeah, it's coming from the fact that both sides of this were negative. And then when I took the logs off, I said, oh, well, we'll just allow everything there, right? But really, this thing was only going to deal with positive here, positive there. You see that?
So did you get, never mind, this morning you got the 7t plus 3 from adding t plus 1?
This 7t plus 3 here?
Yeah, I just noticed that.
So I multiplied both sides by t plus 1 to get the t plus 1 out of the bottom here.
Okay. Oh, never mind, I see it, I was just,
Can I make a sort of a broad statement about your testing procedure here?
Yeah.
So labeling sections that I was doing stuff from, right? This thing is like an 11.5 thing, right? That log rule. This is like an 11.3 thing where I get rid of the logs. This business here, what's that? Yeah, this is like chapter 9, right? That's solve an equation with scary fractions. You see that? So that's like a chapter 9 style thing. What's this business? So like, I did the chapter 9 thing, I got to here, I FOIL, which I maybe learned in Algebra 1 or something. And then I did some stuff, I got to here. Then what was this business to the end?
7 or 8.
Yeah, that's like chapter 7 or 8, depending on whether you factor or use the quadratic formula. You guys see that? This stuff really is Algebra 1. Cool. So when I tell you your final is kinda cumulative, what I mean is I'm probably not going to ask you specifically factor this thing, right? I'm not going to ask you one of these guys. But if you can't do one of these guys, you're going to have trouble finishing off the problems from chapter 11. Cool? So studying maybe your past tests is a good idea to get used to the kind of problems you might have to do at the end. But don't focus on it, right? 50% of your exam isn't going to be like chapter 8 problems. The chapter 8 problems are going to come at the end of a chapter 11 problem. Cool?
Yeah, quite see, I need to.
So it's a little bit less like I'm asking you chapter 8 stuff, and maybe a little bit more like I'm going to accidentally punish you for not knowing it. Cool? So philosophically, take that for what it's worth. Sorry. I do try to make the ends a little bit easy. If you feel like you've gotten to the end of one and you're super bogged down, like it's really getting awful and you're not sure if you've made an arithmetic mistake that's giving that to you, feel free to ask and I can point, say, maybe you should check this number here, or yeah, I would stop doing